All right, ladies and gentlemen, we're taking a look at lesson 1.3. There's a warm-up here. So I know on the notes, the functions are left blank, but I have them filled in. So what I want you to do is to create a t-chart and sketch the graph for f of x equals x squared, g of x equals x cubed, h of x equals the absolute value of x, and r of x equals the square root of x. These are the four that we'll be most commonly dealing with when we get into transformations. So pause the video, get those filled out, and then press play to move on. All right, so you should have the video, or you should have paused the video and have all of this filled in. So the first thing, just to remind you what it looks like, it should be zooming in soon. It's not working. All right. So, anyways, we have -2 to +2 here. There we go. And then I have my corresponding values in my graph. So this is what it should look like for you for f of x equals x squared. So this is what yours should look like. If you're not sure how I got this or filled it out, I would recommend going back to the 1.1 video where I explain filling these out. Here's the next one, g of x equals x cubed. This is what your graph and table should look like. And you might be wondering, well, it was f of x before. Why is it g of x now? The f and the g and the h and the r that I used on the two that are below this is just letters that represent the name of the function. It doesn't change anything. Just how my name is Mrs. Walker and the other Algebra 2 teacher's name is Mr. Brasser to just distinguish between us. But we're both math teachers. Well, these are all functions, but they all have their individual names because they represent something a little bit different of a picture. Next, we have h of x equals the absolute value of x. This is what yours should look like. And last, r of x equals the square root of x, and this is what yours should look like as well. Now, your tables on each of these might be a little different if you use different x values, but the shape of them should all be the same. Now, I'm going to be relying heavily on using these tables and these graphs throughout the next couple of lessons to talk about transformations. I really like working with the parent function's original image or original table and then transforming that because it just makes it a little bit easier to wrap our heads around how the numbers and values are really changing and what exactly is changing on this parent function to the new function once a transformation has taken place. Now, these transformations I'm talking about are things like moving the graph left or right or up or down. And sometimes we reflect them. Sometimes we're going to stretch them really tall or squish them down to be then really wide. And so these are the types of transformations you'll be seeing in the upcoming lessons. Now, when I go through them, I use these parent tables is what I call them. So the numbers I've chosen here and on this page of what I just walked you through, I will be using those a lot throughout the upcoming lessons. So if you use different numbers, just know that it'll still work for whatever numbers you chose. Just your transformation from the parent table, what I'm calling the parent table, just might look a little bit different in terms of values. Okay, so if it's easier for you to use the same numbers as I did, then I would recommend doing that. All right, so let's get started. So 1.3 is all about shifts. It says throughout these lessons, we'll be starting with a function and then we'll be transforming it. The very first transformation of shifts is moving the graphs side to side or up and down. So just how we have a horizontal axis and a vertical axis, you're going to notice that in today's lesson and the upcoming lessons, we go about them by talking about first what is the vertical transformation and then what is the horizontal. So we break it down to say this is how it looks when it's affecting it vertically and this is how it looks when it's affecting it horizontally. We're going to try and take this slow and just do one piece of a transformation at a time, but in the end we are eventually going to start combining these transformations together and having multiple things happen to the parent functions at once. So just be mindful of that, but we are going to take it slow and just do one piece at a time and learn about each of these individual transformations. Then we'll begin putting things together and doing multiple transformations at once. So the very first thing you're going to want to highlight on this page or make sure that you make note of are vertical shifts. It says let g of x equal f of x plus k. Now, I know that this is really mathy notation here, but what this is saying is when you notice something like a plus k on the end of some original parent function, that is causing a vertical shift. Specifically, the graph of g is obtained from the graph of f by shifting up k units. So that plus k is going to move the whole graph up that many units. So all the points will all get moved up that many units for whatever k is. So looking at this first example, f of x equals x squared, g of x equals f of x plus 3. Again, I know that this is really mathy notation, but what we want to focus on is the piece that's changing, this plus 3. Because what that means for us is all of these points from the original to the new, we're getting shifted up 3 units. So I could pick any point on this red graph and move it up 3 units, and that would bring me to the blue graph. The graph can also be obtained by using a table. So there's a couple of ways you can apply the transformations. You can graph the original function, like it is in red here, and then move all of your points up 3 units to get your graph in blue. Or you can use tables, and so that's what I'm going to walk you through next. When I'm using tables, I always start by writing down the original parent function, which for us was x squared. Oops. Let's move this. So all I'm doing right now is recreating the parent table for the quadratic function. So we've already gone through and created this table for the parent quadratic function a couple of times now in 1.1 and in the warm-up of this lesson. Now it says that we are adding 3, meaning all of my values are getting shifted up 3 units. Now going up, that's vertical, and your vertical axis is the y-axis. So notice how all these points are going to be still keeping the same x values, but it's the y values that are going to be increasing by 3 here. So using tables then, because this is a vertical movement, all of my x's from the original table are not going to be affected because the x-axis is horizontal and this is a vertical transformation. So what I'm going to do then is I'm just going to transfer my x values over to this new table. But what is going to change, what is being affected, is the vertical values, all of these y values. And I know it says f of x, that's just function notation. It's the same thing as y. All of these y values need this transformation of plus 3 applied to them. So then we would get 7, because 4 plus 3 is 7. 1 plus 3 is 4. 0 plus 3 is 3. 1 plus 3 is 4. And 4 plus 3 is 7. So if I graphed this in red, I would get this graph. And now graphing these points in blue, I would get this graph. I'm not expecting you to feel 100% after this first example. This might take a little bit of time, but that's why we're taking this a little bit slower. All right, so we're going to go through another example below, talking about when graphs get shifted down, and that'll be in the next video.